Alright, so here we are in the fractions review. We've done the factoring review. We're going to do the fractions review now, jumping straight into it. We want to add the two fractions. Now when you add the two fractions, you need to have the denominators be the same. So right now they are different, 3 and 5. They need to be the same, so we're going to manipulate each fraction so that they are the same. So first we're going to look at 2/3. We're going to say, what's the LCD of 2/3 and 4/5? And if we look at 3 and 5, if we times 3 up to and we times 5 up to, we find the commonest thing that they can both reach is 15, which is this themselves multiplied by each other. So 3 times 5 is 15. So the LCD is 15. We need to manipulate 2/3 so that it has a denominator of 15. Well, we know that multiplying 3 by 5 would get 15, so we're going to multiply 3 by 5. But we don't want to change the value of this fraction, and so we know that multiplying a number by 1 won't change its value. And we also know that 5 divided by 5 is 1, so any number over itself is 1. So if we multiply, and when we multiply, we go straight across. We have 2 times 5 is 10, 3 times 5 is 15. So that's our first fraction rewritten. And these should be the exact same. So 2/3 is the same as 10 over 15. So now I'm manipulating 4/5. We want the bottom to be 15. We know that 3 times 5 is 15. So we're going to multiply 5 by 3, but we don't want to change the value of 4/5, so we need to make this fraction 1. So 3 divided by 3 is 1, so it won't change the value of 4/5. So 4 times 3 is 12. 5 times 3 is 15. So rewriting this, going down here, it's 12 over 15. And now the denominators are the same, so we can add. So 10 plus 12 is 22 over 15. So we've successfully added those fractions. So next we're going to add these fractions, or try to. Now when you see something that's divided by 0, this is indeterminate. Okay? If the 0 is on the denominator, it's indeterminate. Which means we don't know what this means to divide anything by 0. So trying to do anything with an indeterminate number is nonsense. So you cannot do anything with this expression. It's meaningless. We have no idea. Moving on to the next one, we want to subtract. We have 2 divided by 9 minus 3. So we can actually add a 1 under the 3, because 3 divided by 1 is just 3. So we have 2 divided by 9 minus 3 over 1. And we want to make this 1 and the 9 be the same. And the easiest way to do that is multiply the 3 over 1. So if we multiply the 3 over 1, we need to make this denominator be the same as this one. So we're going to multiply to get 9 on the denominator. We're going to multiply 1 by 9. We don't want to change the value of this 3, so we're going to multiply the whole thing by 9 over 9, which is 1. So 3 times 9 is 27, and then 1 times 9 is 9. And if you say 27 divided by 9, it's 3. So we can rewrite this as 2 over 9 minus 27 over 9. And now you can go ahead and subtract. So we have 2 minus 27, which is negative 25, and the denominator carries. So 2 divided by 9 minus 3 over 1 is negative 25 divided by 9. So when you add and subtract fractions, they have to have the same denominator. Moving on to multiplication, we want to multiply 1 divided by 7 times 14 over 3. So when you multiply, all you need to do is go straight across. You don't need to have the same denominator. It'll work if you have the same denominator, but you don't need to have the same denominator. So 1 times 14 is 14, and 7 times 3 is 7 times 21. And we can simplify this fraction because these both have 7 in it. So 14 is 7 times 2, and 21 is 7 times 3. So they both have 7 in it. This is the same thing as 7 over 7 times 2 over 3. 7 over 7 is 1. It's the same thing as 1 times 2/3. So we can just say this is 2/3. And we actually could have taken out the 7 earlier, because we have a 7 here and a 14 here. We could have said, hey, there's 1 7 here, and there's 2 7s here. And you would have gotten 1 over 1 times 2/3. So there's an easier way to do it, but if that doesn't make sense, then just here's how it works. Okay? So that's multiplication. We're going to move on to division. So we want to divide 4/5 by 8 over 3. So when you have fractions that you divide, you're going to take the first one and keep it as it is, but you're going to take the reciprocal of the second fraction, which means you're going to flip this and then multiply. So this is the same thing as 4/5 times, instead of dividing, and we're going to take the reciprocal of 8 over 3. So we're going to flip the 3 onto the top, and we're going to take the 8 down to the bottom, like that. So now we have a multiplication problem, which we know how to do. We go straight across. 4 times 3 is 12, and 5 times 8 is 40. And these both have 2 in it, so we can take out a 2. This is 2 times 6, and 40 is 2 times 20. Looks like we can take out another 2, so we can take out 2 from 6 again. We get 3, and then 10. So this simplified is 3/10. That's how we do that. You also could have simplified it up here. We notice that 4 and 8 both have 4 in it. You could have said this is 1, and there has 2 4s here. And then you would have had 1 times 3 over 2 times 5, which is 3/10. So there's another way of doing that. So now we have this problem, and at first you may think, oh no, this is indeterminate, but the zero's on top. Now 0 can be divided by anything, but you can't divide anything by 0. So if 0's on top over whatever number, it's good. But if 0's on the bottom, it's bad. Okay? So 0 on top, smiley face. If you're on the bottom, very sad face. Okay? So that's how you work. So this is the same thing, but 0 divided by anything is 0. So this is the same thing as 0 divided by 8/3. And 0 divided by anything is also 0. So this is just 0. It all just goes down to 0. So the next one, we have this example. We have 4 divided by 5 divided by 8 over 0. And you may think, well, when we multiply, we can flip this. However, because this is the original fraction, it's still indeterminate. We still don't know what to do with it. So we just say it's indeterminate. And we can't do anything with it. Okay? Doesn't matter what we can do, if we can flip it or not. It's still indeterminate. If there's a 0 in a fraction anywhere at the beginning, then we can't do anything.